And there we go. Okay, so solve using the quadratic formula. Okay, so let's try that one. So let's move on and do the formula. Okay, so first the quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so the obvious question here is, well, what's a, b, and c? Because we have to plug them in, right? Okay, so in this case, you have ax squared plus bx plus c, right? Okay, so right here, I'm just going to rewrite this because I want this to be set equal to 0. So I'm going to rewrite this as x squared plus 8x. But since I move the negative 15 from the right to the left, it's going to turn into a plus 15 equals 0. Okay, so we know the implied or understood coefficient in front of the x squared is a 1, right? So that's going to be a is equal to 1. How about b? Well, b is going to be the 8. And how about c? Well, c is going to be the 15. Okay, so we've identified our a, b, and c. Okay, let's plug it in. So now we're going to plug everything in here, right? So we say negative b, b being 8, plus or minus b squared, which is 8 squared, minus 4 times a is 1, and c is 15. So we're up to that point right there. Let me say 2 times 1, because again, a is 1. Okay, now we need to simplify this radical. That's where most of the simplification goes. I'm actually going to do it way over here, just to give myself plenty of room, because this is going to be one of the more complicated things. So I usually do a little side work and do it over here. We say 8 squared is going to give me a 64. Negative 4 times 1 is negative 4. Negative 4 times 15 is negative 60. 64 minus 60 is 4. Square root of 4 is 2. So now I'm going to go back over here, and that is a negative 8 plus or minus 2 all over 2. Okay, now we have a positive and negative version of this that we want to deal with. So we have a negative 8 plus 2 divided by 2. Negative 8 plus 2 is negative 6 divided by 2, which gives me a negative 3. Then we do the other version, which is negative 8 minus 2 all over 2. Negative 8 minus 2 is negative 10. Negative 10 divided by 2 is negative 5. All right, and at that point we have a couple of answers, right? So we have negative 3, and we have the negative 5. So we got our two answers from that one. And they were both real answers, so we're good. A rectangular parking lot has a length that is 3 yards greater than the width. The area of the parking lot is 180 square yards. Find the length and the width. Now, since we're dealing with the area of a parking lot, I'm assuming that's a rectangular parking lot because it's talking about length and width. We know there's a general form, and it talks about square yards, which is an area. Okay, so we're dealing with the area of a rectangle. So since I identified I'm dealing with the area of a rectangle, it's got several clues in here. Area of parking lot, it talks about square yard, talks about length and width. Lots of indications of the area of a rectangle. So we know it's area is equal to length times width. So like there. Okay, cool. So we wrote our general equation right there. Now we want to define our variables. Do we know what A is? What's the area? Well, it's 180 square yards. I'm leaving out the units. I'm being lazy. What about length? Do we know what the length is? The length is 3 yards greater than the width. Okay, cool. So it's width plus 3. Or what's width? Well, width is just width. So we're just going to leave it as width. All right, I can even do this. That's not necessary, but you can do that. Okay, now, so we've defined everything. Okay, so we wrote the general equation. We defined all of our variables with the information they gave us within here. And now we plug it all in there. So where it has an A, we put in 180. Where it has L, we put W plus 3. And where it has W, we just leave W. Okay, so we distribute the W within the parentheses. Okay, W times W is W squared. W times 3 is 3W. Next, this is a quadratic equation because we have a 2 power right there. That's a quadratic. And we solve it by setting it equal to 0, minus 180, minus 180. And there we go. Cancel, cancel. Because this 0 is equal to W squared plus 3W minus 180. Okay. At this point, we set it equal to 0. If you're solving a quadratic, first step, set it equal to 0. Next step, if you're going to use the zero factor properties, you can try to factor it. We might be able to factor this one, so I'm going to try it out. Square root of W squared is W. We end in a negative, so they're going to have opposite signs. it ends in a negative 180. So we're looking for two numbers that we can multiply together to give you a negative 180, that if you add together would give you a 3. It might seem like that's kind of an overwhelming number, but you don't have to write every possibility here, right? Again, there's most of these numbers, the first ones, you know they're not going to work. So feel free to skip around. You're looking for something really close to the middle of this. And it's not a bad idea to skip the first few and go straight to the ones you're a little more sure about. Okay, so because this number is really large, the negative 180 is really large, and the middle one is really small, the square root of 180 will give you around where it is, which if you took the square root of that, I don't know what it is, but it's going to be really close to a 12 or a 15. You're either going to go down one step and you're going to hit the 12, up one step you get 15. So that's a trick. So again, you just basically say 180 and take the square root, and that would give you approximately one of those, the 12 or the 15. Okay, cool. Now they're opposite signs, and the middle term is a positive 3. So the positive is the stronger one over here on the right, and you know the one on the left is the negative. Negative, 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 negative. I'm too lazy to do another row like this, but basically if we added those together, we want to get a 3 difference, and it's this one right here. We get a 3. So we know this is going to be the one. I know I skipped a step, but hopefully that still makes sense what we're doing there. Okay, so we are going to be using a negative 12, and we're going to be using a positive 15. Okay, so now we're going to set those equal to 0. So we say w plus 15 equals 0. So again, we set the quadratic equal to 0. We factored everything. Then we're setting the factors equal to 0. So w minus 12 is equal to 0. So this is going to be w is equal to negative 15. That doesn't make sense. W is equal to positive 12. That makes sense. Okay. Now, given there's nothing wrong with the algebra, but given that we're talking about an actual object, it wouldn't make sense to say that this parking lot has a negative 15-yard width. That doesn't make any sense. Okay. So this one just doesn't work because with the context of the word problem, it just doesn't make any sense. Okay. Now, the w equal to 12, that does make sense. That works. Now, there's a problem, though, because it wants to find not just the width, but it wants to find the length. We know that the length is equal to width plus 3. We have it defined over here at the very beginning, right? Width plus 3. So what we can do is we can say length is equal to 12 plus 3, which simply means length is equal to 15. And then we can verify it, right? If we wanted to, we could go back and plug it in. A lot of word problems you can verify. So you would say the area is equal to 12 for the width multiplied by 15, which means it gives you 180. So it looks like it checks out.